Okay, we're going to look at section 2.2, and we're dealing with quadratics. So a few things that you need to just remember. If we know that it's a quadratic function, it's going to be forming a parabola that either opens up or down. And just by looking at your equation, you'll be able to determine, does it open up or down? And the way that we determine it opening up or down is we look at what we call our A. So let's look at vertex form. I would ignore your book because every mathematician I know calls this the vertex form when you have A times the quantity x minus h squared plus k, because it gives you the vertex. Notice when it's in that form, hk will be your vertex, much like when we did the equation of a circle, hk was the center. So let's look at number 1 and just talk about the format. This is your A, -2. Notice then your H is going to be 3, and then your K is going to be 8. So just by looking at this equation, I should be able to determine, does it open up or down? Well, since your A is negative, that is opening down. So it's going to be a parabola, but it's going to open down. Now, the second thing I'd like you to see if you can determine is the vertex. Well, when it's in vertex form, you've got the vertex is going to be 3, 8. And so I could plot that point, 3, 8. And the great thing about the vertex is once we know the vertex, every parabola has an axis of symmetry that always goes through the vertex. So I now know that I'm going to have this line of symmetry that goes through that vertex. Now, since I know that the parabola opens down, the other thing I should be aware of is this is going to be my max. If it's opening up, then this is going to be the point where a minimum occurs. So once we have our vertex, a few things, of course, you can do a couple points to the left and a couple points to the right, and there's nothing wrong with that. But I also just want to remind you to use your intercepts. If you are looking for real zeros, we refer to that as real zeros. Those are also your x-intercepts. That's when f of x equals 0. So I just want to remind you, I'm going to do the work, I think, over here since I have more room. So when your function is f of x equals -2 times the quantity x minus 3 squared plus 8, if you're wanting to find your x-intercepts, you can just plug in 0 for that f of x. And then you're just solving your equation like you normally would. Most of you would subtract 8, probably first, and then you would divide by 2, which gives us 4 equals the quantity x minus 3 squared. Then you could take the square root of both sides. Remember, you should get plus or minus 2 on the left equals x minus 3. So your two equations, move that up slightly, your two equations are going to be x minus 3 equals 2 and x minus 3 equals a -2. And then, of course, when you solve that, you're going to get x equals 5. So remember, your y value was 0, so you're going to have a point at 5, 0. And then when you get your other x-intercept, you're going to have a point at 1, 0. Now, something to also keep in mind, clearly a parabola, it's going to have symmetry. So notice if you have an x-intercept that's 2 units from the line of symmetry, you should have another point that is 2 units from that line of symmetry. So don't forget about using your x-intercepts. You can also, of course, use your y-intercepts if you have a y-intercept. And there's when you plug in f of 0. Basically, x is 0. So I'm going to move this up a little so I have some more room. So when you have your y-intercept, I'm going to plug in, here's my function. I'm going to plug in x is 0, because f of 0 is when you're plugging in that 0 for your x value. So this is going to give us what? -2 times, that looks like it's going to be 9, and this is going to be -10. So you should have a point at 0, -10, which means you'll have a complementary point on that other side. There's nothing wrong, if you wanted to plug in like 2 and get your value. I think you'll get 6. Oh, sorry, it's wanting to jump on me. And there you have your quadratic. I'm not going to go further than those points. And you're just going to have a smooth curve. And that is the vertex form of a quadratic function.